Hi and welcome back. So let's use the periodic table in this example to try to figure out how many valence electrons a few different elements have. So let's start out with barium. So barium is a group 2 element. So barium is like all group 2 elements, like all elements that are going to be in this row, it's going to have 2 valence electrons, right? Because its electron configuration. So this I'll just write down. It has 2 valence electrons, and remember that any element that is in this group 2, is going to have what are the last 2 electrons that you would write in the electron configuration for any element in this group? Well, it would be whatever period you're on, S2, right? That would be, so it would be the highest period number that you had. So in the case of barium is in the 1, 2, so it's in 1, 2, 3, 4, 5, 6. It's in the 6th. It's in the 6th period. So we could, let's even just write real quick. Let's write the nearest noble gas configuration for barium. So it would just be the same as xenon, but we're just going to add on 6s2. So these are the electrons that have the highest principal quantum number. So therefore, barium is going to have 2 valence electrons. Let's do another example. So let's say, what's another good one? Let's take the example of sulfur. Let's say I had sulfur. So sulfur is right here, and sulfur is right under oxygen. So we know that our halogens all have 7 valence electrons, and we could count across the periodic table, where even this might be a good idea to just label how many valence electrons each of these rows have. And let me do a nice dark color. So we know that this row is going to have 1 valence electron. Then this row will have 2. Then this row starting with boron will have 3. Carbons row will have 4. Nitrogens will have 5. And then the row that we're looking for will have 6. And then this last row will have 7. And then our noble gases, those will all have 8 valence electrons. So sulfur, down here, sulfur is an oxygens row. So that is going to have 6 valence electrons. And what would the let's just do real quick the electron configuration look like for sulfur? Let's just do the nearest previous noble gas configuration. It would be neon. So it would be the same thing as neon. But we're going to add on 3s2. 3s2, so 2 electrons in the 3s orbital. And then we're going to add on 1, 2, 3, 4 electrons in the 3p orbital. So 3s2, 3p4. So therefore, you can see that the number of electrons with our greatest quantum number, so our greatest principal quantum number in this example is 3, and the number of electrons that we have in this example that have that principal quantum number is 6, because 2 plus 4 is equal to 6. So that is how many valence electrons sulfur has. In the next few videos, I'll just keep doing a few more examples. So thanks for watching.